What's up, guys? Welcome back to ASVAB Roadmap. Today's video is about understanding exponents and their operations. So let's get right into it. By now we have the four basic arithmetic operations down. Those being addition, subtraction, multiplication, and division. But of course, there will be many more to learn in this course. The next operation we will learn is how to raise some number to a power, or exponent. When we do this, we have a base that is written normally, and an exponent that is written as a superscript. Just the way that multiplication represents repeated addition, exponents represent repeated multiplication. 2 times 3 is really 2 plus 2 plus 2, while 2 to the third power is 2 times 2 times 2. When we raise something to the second power, we are squaring that number. So we can say 5 squared. When we raise something to the third power, we are cubing that number. So we can say 5 cubed. In each case, we can write down the base number, the number of times indicated by the exponent, and do the multiplication, which gives us 25 and 125 respectively. Sometimes, instead of the superscript, we might see this little hat symbol here. And when we see this, the first number is the base, and the second number is the exponent. So this is 5 to the fourth power. This is needed when someone has written an expression without access to the superscript function. And this symbol is needed to imply exponentiation. One thing we will notice almost immediately is that with exponents, numbers get very large very fast. Let's try a few examples to practice. What is 3 to the fourth power? That would be 3 times 3 times 3 times 3, or 81. What about 6 to the fifth power? Well, that will give us 5 sixes to multiply, which will also equal 7,776. Is it possible to raise a number with a negative exponent? In fact, yes we can. When raising to a negative exponent, we simply invert the term and make the exponent positive. So 2 to the negative 2 is 1 over 2 squared, or 1/4. Let's learn the rules of manipulating terms raised to exponents. X to the a times x to the b equals x to the a plus b. This must be true because let's say we have x squared times x cubed. That could be written as 2x's times 3x's. But that's now just 5 x's in a row. So we should be able to call this x to the fifth. For division, it's the opposite. X to the a over x to the b equals x to the a minus b. Again, this makes sense if we do something like x to the fifth over x to the third. If we do something like 5x's over 3x's, we can see that 3 of the x's cancel. The number of x's left is the number of x's on the top minus the number of x's on the bottom. Hence, x to the a minus b. Lastly, if we do x to the a power, that is then raised to the b power, it equals x to the a times b. Let's say we have x to the fourth to the second. That means we have 4 x's, and then that whole thing is squared, meaning we have 2 sets of 4 x's. That's 8 x's total, or x to the 8th. So these expressions summarize the rules for manipulating terms that are raised to exponents. Let's notice that x to the a plus x to the b is not listed here because there's nothing we can do with that. Those are 2 separate terms that can't be combined in any way. Alright guys, that was understanding exponents and their operations. Be sure to work on the practice test with your newfound knowledge, and I'll see you inside of the next video.